Welcome, this is section 9.2, which is infinite limits and limits of infinity. So let's go ahead and take a look. Again, you will start with your textbook, you will look at your PowerPoint presentations, you will start working on your homework and then use this video as a resource to complete your homework. And again, it's very important to have that concept and understanding. Without that, trust me, this is going to be very confusing. And please make sure that you know that you can use a note card during your test and make sure you write down the formulas as you work with your topics. So here it says limits of power functions. Now let's go ahead and take a look. Here, my power functions are in the denominator. So when the power functions are in the denominator, limit x goes to negative infinity or limit x goes to positive infinity, the function value is a 0. When the power functions are in the numerator, and when I have limit x goes to negative infinity or positive infinity, then the function value is either positive or negative infinity. Now let's take a look at the rational functions. Rational function is again when you have a function on the top and function in the bottom. And as you can see here, I have the entire rational function, and when I'm looking at the limit when x goes to positive infinity or x goes to negative infinity, what I want you to notice, we only look at the leading term. We only look at the leading term here. The rest is all gone. What do I mean? Let me give you an example. If I have a function f of x is equal to 7x cubed minus 4x squared plus 3x, and in the denominator I have x minus 2x plus 8x to the power 5. Then the leading term here is 7x cubed and the leading term here is 8x5. When I'm considering the limit when x goes to either positive or negative infinity, I do not take any of these into consideration. I only look at the leading terms. Once I have that, let me move this all the way here. Once I have that, these are my conditions. If the power of the numerator, you know what, let me bring all of this here. Okay, now let me expand. If the power of the numerator is less than the denominator, so m is the power of the numerator, n is the power of the denominator. So power of the numerator here, I have 3, which is less than 5. Then limit when x goes to negative or positive infinity is simply 0, which is your horizontal asymptote. Now let's go ahead and see when my power is equal. So when the power of the numerator is same as power of the denominator, then my limit when x goes to positive infinity or negative infinity, the function value would simply be 7 over 8, which is the coefficient of the top by coefficient of the bottom. Now we have another case when the power of the numerator is greater than the denominator, then my limit simply goes to positive infinity or negative infinity. Now let's go ahead and take a look at the first problem. Refer to the graph on the right and describe what is happening to the function when x goes to negative 2 from the positive side. Not a problem at all. Here is my graph. Where is my negative 2? So here I have my function x is equal to negative 2, and I'm trying to see what happens to the function when I come from the positive side. When I'm coming from the positive side, as you can see, the function is going towards negative infinity. So when limit x goes to negative 2 from the positive side, the function goes to infinity. Probably this color is not good. Let me go ahead and change the color. Let's see. I'm going to change it to black. There you go, much more clear. Okay, so I'm simply looking where the function is going, and the function goes to negative infinity. Now let's go ahead and take a look at the next one. For this problem, I want to go ahead and graph it and show you what's happening. So this is the graph. Let's see, where is it? So I graphed the function, right? That's how the graph looks like. And as you can see, when this is my graph, let me graph something else. Let me graph x is equal to 9. when I'm graphing the graph x is equal to 9, when I'm coming from the positive side, as you can see, the graph goes to, the value goes to negative infinity. When I'm coming from the negative side, the value still goes to negative infinity. That's one way of looking at it. Again, when I'm coming from the positive side, look where the y values are going. They keep increasing, going all the way up to negative infinity. That's one way of looking at it. Or if I start to work with this function here, all they're asking me to do is find the limit when I go to approach x from the negative side. So all I have to do here is I'll take the function negative 9 x minus 9. Is that negative? The whole thing is negative. Okay. I don't know why they don't put parentheses, I think just to confuse you all. X minus 9 whole squared. So I'm approaching 9 from the negative side. That means so all I have to do is take a value of x as 8.9999 and see what happens. Let's go ahead and do that. Again, you can use any graphing calculator. I'm just using this one because it's easy for me to show you. So I'm going to take 8.99999. As you can see, it goes to negative infinity. Now let's see what happens when I approach 9 from the positive side. Positive side is greater than 9, so 9.11111. As you can see, it's still approaching negative infinity. Now, that's one way of doing it. Or, like I said, take x is equal to negative 8.999 and plug it into the function. So when you plug this into the function, you will have negative 9 times 8.99999 minus 9, and then whatever the value you get, that is going to be negative infinity. Keep in mind, you're not finding the value, you're just trying to see what is happening to the function when, where is it? What is happening to the function when you approach 9 from the negative side and you approach the function from the positive side. As you can see, both of them are going to negative infinity. So when I approach from the negative side, I go to negative infinity. When I approach from the positive side, I go to negative infinity. And again, this is something that you have to know. If limit x goes to c, f of x from positive c is equal to same as, let me close this one, same as limit x goes to c from negative side. Let's just say that is some value n, then the limit of the function is n. What I mean is it is negative infinity when you're approaching from negative side. It's negative infinity when you're approaching from positive side. So the limit of the function is negative infinity. Again, you can graph it, you can plug it in. If you're plugging in, make sure you plug everything, which I don't really recommend because it's going to be a lot of, oops, that's not how it's supposed to be. This is going to be 8.999. How many nines you take on the top, you have to take so many decimal values. And then again, this is going to be close to negative infinity. You can take the same thing for here too and plug it in and see which one works. All right, let's take a look at the next one. Again, I like to graph these and see what's happening. Here I have find the leading term. Again, the leading term is the term that has the highest power, which is x power 3. And the limit x approaches, what happens when limit x approaches positive infinity, when limit x approaches negative infinity. Again, what I'm going to do is I'm going to go ahead and pull this up here. You can graph it. I'm going to graph 4x plus x cube minus 7x, minus 7x squared. And as you can see, this is a cube function. This is a cube function. And what they're asking me is, hey, what happens when x approaches positive infinity and when x approaches negative infinity? In the other words, what is happening to the function value? So when x is going to positive infinity, as you can see, the graph goes to positive infinity. When x is approaching negative infinity, the graph is going to negative infinity. That's one way of taking a look at the problem, at the graph. Or you can take a value. When x is approaching positive infinity, take your x value as, take a big number, 8, 9, 7, 6, 4, 3. And when x is approaching negative infinity, which is negative 8, 9, 7, 6, 4, 3, and plug these into the function values and see what's happening to the function. That's another way of looking at the problem. But I would like to look at the graph, and as you can see, here is my graph. When x is approaching positive infinity, my y values are also approaching positive infinity. X is approaching negative infinity, my y values are approaching negative infinity. Now let me close this one. Now let's go ahead at the next one here. Function value, that is very simple. All you have to do is plug in negative 10 into the function. So this is going to be 14 minus 6 times negative 10 cube over 5 plus 10 cube, and that would give you negative 6.044, rounding off to the thousandth value. Now f of negative 20, same thing, 14 minus 6 times negative 20 whole cube over 5 plus, oops, this is negative 20 whole cube, and that would give you approximately negative 6.006. You can plug into the calculator, or you can simply graph it and find the function value. Now the next challenging question is this one. What happens when x goes to negative infinity? So let's go back to the rational function. Remember what we talked about? When, let me erase this one. When the limit x approaches positive or negative infinity for a rational function, you only consider the leading term. So let's go ahead. Here it's approaching negative infinity. So that means I will not be considering this term here. I will not be considering this term. The only terms that I take into consideration are negative 6x cubed and x cubed. Now what do I look at? I look at the power. The power of the numerator is equal to power of the denominator. When power of the numerator is equal to power of the denominator, your limit is simply coefficient of the top over coefficient of the bottom. So that is, coefficient of the top here is negative 6. Coefficient of the bottom is 1. So this is negative 6. This is nothing but your horizontal asymptote. Now, this is a good time to refresh what your vertical and horizontal asymptotes are. Let's go ahead and take a look at the next problem. Oh, here you go. Here I have find the horizontal and vertical asymptote. So let me go ahead and write this down all the way at the bottom here. My function f of x is equal to, what is it? X squared plus 16 over x squared minus 16. Here they're asking me to find vertical asymptotes. To find vertical asymptote, you simply take your denominator and set it equal to 0. So now I have x squared minus 16 equal to 0. That means my x squared is equal to 16. That is, x is equal to positive 4 and negative 4. So your vertical asymptotes are x is equal to positive 4 and x is equal to negative 4. That's how you check your vertical asymptote. Now coming to horizontal asymptotes, when it comes to horizontal asymptotes, I want you to look at the power. What is the power of the numerator? Power of the numerator is 2, denominator is 2. So when the power of the numerator is equal to power of the denominator, your horizontal asymptote is nothing but y is equal to, coefficient of the top over coefficient of the bottom, which is 1. And again, that goes back to this rule where the power of the numerator is equal to denominator. I simply take the coefficient of the leading term divided by the coefficient of the leading term in the denominator. Okay, so that is going to be your horizontal asymptote and vertical asymptote. Remember, horizontal asymptotes are x equal to, and your vertical asymptotes are y equal to. Now let's go ahead and take a look at the next problem. A company is planning to manufacture snowboards. The fixed cost, okay, so this is a fixed cost per day, and the total costs are 5,000 per day at output of 20 boards. The first question says, assuming the total cost per day is Cx is linear related to the output x, write the equation. All right, very good. So let me expand this one so you can see much more clearly. They're asking me to write the cost C of x in terms of x. So 400 is the fixed cost. So there will be 400 no matter how many units you produce. Plus, let B be the cost per unit and x be the number of units. Okay, so B is the cost, X is. Now, if you look closely, this kind of mimics Y is equal to mx plus B. Actually, you know what? Let's take it as M here so you don't have any confusion. Let M be the cost per unit and X is the number of units, mx plus B. My B is my intercept, which is here. I'm trying to find the slope. But here they gave me a clue. They said, hey, if you produce 20 units, you will spend $5,000, which is right here, 20 and 5,000. So now to find my M value, this is my X, this is my Y, I will simply plug in 5,000 in place of C of X, and I will plug in 20 in place of X. Let's go ahead and do that. I should have some space somewhere. Okay. So I have C of X is equal to 400 plus mx. And I know that when I produce 20 units, it costs me $5,000. So my 5,000 is the cost and the number of units, X is 20. I'm going to plug in 5,000 is equal to 400 plus m times 20. Subtract 400 from both sides. I end up with 4,600 is equal to 20m. M is equal to 230. So my final equation, C of X is equal to 400 plus 230 times X. And if you plug in your 20 here, you should get back your 5,000. Now I finished the first part. Very good. 400 plus 230x. Now what they're asking me, they said, hey, the average cost per board for an output X boards is given by C of X over X. Oh, that's very simple. I already know what my C of X is, which is 400 plus 230x. Now all I have to do is divide by x and divide by x. Bingo. There you have it. Now what they're asking me is sketch the graph. They said sketch the graph of the function. Sketch the graph of this function. Now look closely here. This is a rational function. And power of the numerator is same as the power of the denominator. When the power of the numerator is same as denominator, my horizontal asymptote is simply going to be coefficient of the top by coefficient of the bottom, which is 230. That means I know that my graph has to have a horizontal asymptote at 230. Let's go ahead and take a look. So this is 100, 200, 300, 400. Oops. Why did I pick the right one? So it's definitely not here because this is 100. As you can see, my horizontal asymptote is not at 100. And this is 1, 2, 3, 300. My horizontal asymptote, it's not at 300. And this is 400. My horizontal asymptote, it's not at 400. The only option I have here is my horizontal asymptote is at 230. Now, what are they asking me? What is the average cost per board tend to as the production increases? Now, this is a perfect example of how you're using your limits. They're telling me, hey, what is the average cost as the production increases? So let me zoom in here, erase this one. So as your production is increasing, as you can see, as I increase from 1 unit, 2 units, 3, 4, 5, 6, all the way to 30, my production cost is getting closer and closer to 230 because that is my horizontal asymptote. So my production cost is going to be $230. A beautiful example of your limits. Oops. Hope this helps.